Hello and welcome to Cup of Cosmology, the place for all your questions about the universe. My name is Diana Hooper and I'm a postdoctoral researcher at the Helsinki Institute of Physics over in the University of Helsinki in Finland, and I'm a cosmologist. So that means that I study the universe, the contents of the universe, the evolution, the history, the future of the universe, lots of cool stuff happening inside the universe. Hey David Howden, great to see you, welcome. So yeah, I'm a theoretical physicist, I specialize in cosmology. And I love talking about science, about cosmology, about the universe, about all of the cool things I get to study. Hey, Scott, great to see you as well. So, yeah, Cup of Cosmology is a place where I can just spend my time chatting about all the cool stuff, and you can ask me any questions you want. As always, this is an interactive stream. The idea here is that you people can ask me whatever you want. You can ask me anything today, you can ask me whatever you want, and I will do my best to try to answer your questions. Ideally, questions about physics, cosmology, academia, science, but you can really ask me anything. I definitely won't have all the answers, but we're going to do our best. We'll see. We'll see where we go today. Hey, Paul, great to see you. Welcome. So to all of the regulars tuning in, it's always lovely to see you. Welcome back. For any first-time viewers, welcome to Cup of Cosmology. I hope you like what you hear. If you do like it here, please do like, leave a comment, subscribe, do all of the usual YouTube things. It really does help boost my audience. So I really do appreciate all of you who interact on YouTube and leave comments and do stuff like that. And of course, to everybody who hypes up Cup of Cosmology on Twitter or on whatever other social media you're on, always lovely to see so many of you chatting and engaging and interacting with the show and with me. So thank you for that, everybody, and do feel free to subscribe if you haven't done so already. Hey James, hey David Dunn, hey Cosmo Blend, lovely to see all of you here. If anyone doesn't follow Cosmo Blend on YouTube, you absolutely should as well for more cool cosmology, this time cosmology visualizations. James says you're walking to a cafe, we'll ask nutty questions in 5 minutes. Well, I look forward to them. And bring your coffee, ask questions. This is Cup of Cosmology. Coffee and tea are definitely welcome. I have my tea that's going to be too hot to drink. Hey Ange, hey Michael, nice to see everybody here. Nice to see all of you tuning in. So yeah, today is an Ask Me Anything. You can ask me anything you want about the universe, and I will do my best to answer the questions. The reason I don't have a topic prepared this week is because I gave an outreach talk 2 days ago, and I'm giving another outreach talk on Friday this coming week, so they're 1 week apart, and then I'm giving another talk the week after. And I'm also supposed to be doing a bunch of other things this month. I may have said yes to a lot of things because January seemed very far away and very distant. And suddenly January's here and I have a lot of things to do. But that means I don't really have time to prepare specific topics for the show right now. So the idea is I just come here, wing it, and see what happens and go in whichever direction people want to take the stream. Whew. I realized I did not take a breath. I just did like 3 minutes of rambling without breathing. Breathing is important. Question from Keith, a duality within a duality as opposed to a single holographic duality. Has that concept ever been considered? I'm really not sure what you mean. As always, Keith, I know you have a lot of questions about the holographic principle and so on. As I said before, I'm not really an expert on holography. I did have a guest on the show talk all about holography. There are plenty of people in my research group who work on holography, and I'm hoping to get more of them come on the show at some point. But yeah, I don't really know enough about holography to enter into long debates with you about duality and things like that. On the timescale you use, even January 30 to 3023, it's close. On cosmological timescales, everything is close by. But it's always that thing that something in the future is easy to say yes. It's like, yes, sure, I agree to this talk. I can write this thing for you, sure. And then suddenly it's January, and I check my calendar, and whoops, I said yes to a lot of things. Great way to start the year, starting with a lot of stuff, a lot of positivity, though. What was the talk about? Give us details. So the talk I gave on Friday, 2 days ago, was on gravitational waves. It's always one of my favorite topics to talk about. So it was a review, an introduction of gravitational waves, what they are, why we should care about them, a lot of cool stuff. I spent an hour just rambling about gravitational waves. And then somebody at the end asked me a question about the CMB, the cosmic microwave background radiation, which, as many of you know, is one of my favorite things in the universe. It's the earliest light we have in the cosmos. It's a snapshot of the baby universe. It's this amazing map here, in case anyone hadn't seen it yet. Less than 6 minutes today. So Someone at the end of this talk on Friday asked me about the CMB, the cosmic microwave background radiation. And I actually replied to this person saying, I'm glad you asked that because the CMB is my second favorite topic after gravitational waves. And then it hit me that I just betrayed the CMB and I just referred to the CMB as my second favorite topic. So yeah, that's what happens if you let me talk about gravitational waves for an hour. I'm going to get so carried away that I'm going to betray the CMB. But it was a really fun talk, probably the most chaotically organized talk I've ever given. There was a lot of chaos happening leading up to the talk, but the talk went really well. It was really fun. And the next talk that I'm giving on Friday, I believe, should be open to the general public. It's going to be a talk that I've never given before, and it's going to be about the first 3 minutes of the universe. A lot happens, and I have the provocative title of What Goes Bump in the Early Universe. And I will check if I'm allowed to publicly share the link. If I am, you can find it on my YouTube chat. I will post it on all of my socials, on Twitter, on Mastodon, on post.news. Yes, I'm on Mastodon, I'm on post.news. I have to say that I'm not going to go into social media conversations. But yes, next week I will be giving another talk. Yeah, it's going to be fun. I have not really started working properly on my presentation yet, but it's a week away, 5 days, plenty of time, full on senior academic mode. And I see there's already a lot of comments and questions, so let me catch up. I see a comment from Paul saying that the person in the audience was a plant. We got somebody to go in and ask about the CMB, would not surprise me. But it was a very lovely question and it allowed me to tie research together. But of course, even though my talk was on gravitational waves, on the 6th or 7th slide, there was already a picture of the CMB in the bottom corner. So the CMB did appear, even though it was very much off topic. Okay, going back to the comments that I missed there. The comment by Paul. Why do we think there is more matter than antimatter instead of thinking that the antimatter clumps might be further away and not seen? I love that you're just starting me off with one of the biggest questions in physics, because this is, if you go to the list of like unsolved questions in physics, you'll find this question there. So awesome. So we know that our universe is made up of matter and not antimatter. Of course, if it was made up purely of antimatter, we would call that normal matter. But in any case, it's one of the two that dominates, and in our case, we call it matter. Now, in the early universe, matter and antimatter should have been created in equal amounts. However, for every 10 billion particles of antimatter, we had 10,000,000,001 particles of normal matter. And it's very good that we did, because as the universe cooled down, all of the matter and all of the antimatter could annihilate. So every antimatter particle looked for a corresponding matter particle and could annihilate and produce photons, the photons that coincidentally make up the cosmic microwave background radiation. The photons, the particles of light in the CMB, actually come from matter and antimatter smashing together in the early universe. Now, the big question here is, why is there more matter than antimatter? Why was more matter created? If these two components had been created in equal parts, they would have annihilated completely, leading to a universe that was just radiation with no matter. Fortunately, there was a tiny bit imbalance. Why did this happen? We have absolutely no idea. Now, as to the way you phrase your question here, Paul, you say, why do we think there is more matter than antimatter, instead of thinking that the antimatter clumps might be further away and not seen? Now, it goes back to this idea that if you have matter and antimatter, they do annihilate. They do come together and annihilate. In order to have antimatter that doesn't annihilate, you would need it to be isolated. Now, we have been able to create antimatter in the universe. We know that there are things creating antimatter in the universe regularly, but these are always very short-lived particles, because as soon as they interact with matter, they are going to annihilate. You can create antiprotons, but then they're going to travel into something and annihilate. And in fact, we measure antiprotons when we see them annihilating with protons. So even though there can be things producing antimatter, if you had a clump of it somewhere in the universe, this would have interacted with other things. It would be very difficult to form antimatter in the early universe that is then stable enough to last until today without finding the corresponding matter part to annihilate with. So it's not so much that we haven't seen this antimatter, it's that it physically couldn't be there in enough. There couldn't be equal amounts of antimatter as there are matter, because inevitably some of that would have definitely annihilated between when it was created and now. So we don't know why there was more matter than antimatter created in the very early universe. We're pretty thankful that that was the case, because else we wouldn't be here having this conversation. but the exact mechanism behind it is something that we don't understand. So why was there more matter than antimatter? No idea. But otherwise, you could take the anthropic principle and say if that weren't the case, we wouldn't be here having this conversation. So it's a moot point because we can only have this conversation because this event happened. But of course, that's not a very satisfying answer as to why this event actually happened. You say 10 billion and 10 billion one. Are you guessing, or are those numbers close? Those numbers are close. Based on the amount of light versus matter that we have in the universe today, there's a lot of light in the universe. We can use this to calculate how much matter and antimatter annihilated. I can't remember the exact numbers. It's either a billion or 10 billion, but it's something with that like really large number where you have one difference. Like there were so many annihilations that you can say this is approximately how many we had. So I would say it's somewhere between a guess and an estimate, and I'm refusing to use the word that people use, putting those two together. So it's around there, around that fraction, but the exact numbers might be off by one order of magnitude. Can antimatter get together and form anti-elements? That is an excellent question. The answer is probably. Billion to billion one. Yes, thank you. So not 10 billion, but billion. So see, one order of magnitude on cosmological scales, that's close enough. Factor 10, up and down, it's close enough. So 1 billion or 10, what's an order of magnitude between friends? Exactly 1 billion, 10 billion, one order of magnitude here or there doesn't really change anything. So can antimatter clump together and form anti-elements? There is no reason to assume that they couldn't, but it's something that, again, is very difficult in any way to see here. There is an experiment, I can't remember where it is, that is working on creating anti-hydrogen. I'm currently trying to remember if they actually created anti-hydrogen or if this was a sci-fi book that I read. But there is an experiment that yes, we have created anti-hydrogen atoms, yes. So there is an experiment that is, I'm really unsure about this now, but there is an experiment that is trying to create anti-hydrogen atoms. They created it. Yes, thank you for confirming that, David. I know there's a sci-fi book where they do that as well, and then it's dramatic and complete bullshit. But yes, they have actually created anti-hydrogen, and its spectra, its behavior is overall the same as hydrogen. But any experiments we do with anti-hydrogen are very short-lived because you have to keep the hydrogen away from any of the normal matter. As soon as it touches the normal matter, is going to annihilate. So there's no reason why we couldn't have larger structures of antimatter other than they already would have annihilated with normal matter. So that makes it quite difficult to actually get complex molecules or structures with antimatter. But that said, if they could, it would be pretty interesting. But it's something that we probably would have seen. It would have annihilated some way or another. So it's quite difficult to actually have this existing now. Okay, going back to the other questions that I missed here, because I know a bunch of you came in with questions quickly, which is great because I love the questions. That's what keeps us going here. And of course, then if I spend 5 minutes answering a question, they pile up, which is great. Keep them coming. I remember when I was doing the streams on Periscope, the questions were coming in constantly, and I would always only answer a fraction of what was asked in the stream. Here, we usually get through all of them. Comment by Michael here. I'm confused about YouTube bait-click videos about new discoveries or new thoughts about the universe because in the videos they don't give any proof. Last I saw is our universe is inside a black hole. What are your thoughts on that? Yeah, so this is a problem not just with science but in general. That a lot of stuff online is driven by clicks, by attention, by making a provocative headline that people have to click on. And it's very easy sometimes to get lost in cycles where you find one over-sensationalized headline, and then it's very easy to find the other ones. And this is always something that bothers me because science is amazing enough as is. It doesn't need to be artificially hyped up. And then you get things like people saying, oh, okay, we're going to look at the multiverse. Like, no, we're fucking not. That's not what we can do. Science is amazing enough. Do not give it this unjustified clickbait nonsense when you can just tell the truth, which is so much more amazing. Yeah, there's also this idea of doing like soundbite science, of reducing scientific facts to soundbites that people can remember. Sometimes that is great, like the fact, you're all stardust. This is memorable. This sticks in your mind. This is scientifically accurate. But this often breaks down. If we take another typical soundbite, it's like gravity is a sheet. It's like, okay, is it though? It breaks down. So this idea of clickbait and soundbite science is something that I really don't like, and it's something that I will try to always avoid doing in the show. I think once I had the title of "Will an asteroid hit the Earth in the next 10 days?" because that was a headline that was going around, and already in the title I put in brackets, spoiler, no. Because I don't believe in clickbait science, but unfortunately there is a lot of it. And I know you were actually asking my thoughts about, is our universe inside a black hole and not about the whole YouTube clickbait thing? But you got my thoughts on that as well. So is our universe inside a black hole? Probably not. However, from a purely mathematical point of view, we don't know what the inside of a black hole is. We have no idea what happens beyond the event horizon. So whatever happens inside a black hole is a complete mystery to us, which means making comparisons between that and something else is rather difficult. Now, you could even say inside a black hole, there's a portal to a library that allows you to come back to Earth, even though you should be dead. Doesn't work, probably. But again, we don't know what happens inside the black hole. So that was a long answer to your question. I don't agree with clickbait science. Science is amazing enough that it shouldn't be turned into clickbait and sound bites and seeing who can get the best clicks. Yeah. And is our universe inside a black hole? Probably not. It doesn't behave. We don't know what happens inside a black hole, so it would be quite odd. In any case, if you see any of these clickbait videos making outlandish claims and you want to fact check them, send them to me and I'll let you know, or ask me here on the show and I'll let you know if it's true, where we stand on that. I always tell you what I know, what is speculative, what we're not sure on, where hypothesis and theory stop. I will always try to keep that accurate. So if you see some random clickbait science headline that you think I'm skeptical of this, please ask me and I will probably tell you, yes, this is nonsense. And if it's true, I will be hyping it up as well. So feel free to also you can always reach out to me on different social media. My DMs are open on every platform that I'm on for now. And so I have had to close them occasionally, but they are usually open. So you're always welcome to send me stuff. And you can always email me, contact@cupofcosmology.com. You can email me just saying, like, is this accurate? And I'll probably write back saying, it's probably clickbait bullshit, but feel free to ask me. I hope you aren't giving us sci-fi info as fact in the past. I try not to, but my brain sometimes remembers things in a weird way. You know that thing where if you daydream enough, then you're not sure if that was actually a daydream or a reality? Yeah, I'm not sure if that's an everybody thing or a me thing, but my brain does that sometimes where you like have a dream that is so realistic that then you're like, wait, was that a memory? Did that actually happen? Brains are weird. You thought it was a stupid question. There are no stupid questions, Michael. There are just unanswered questions. So never feel bad about the questions you ask on the show. And in this case, it was a very good question. But really, there are no stupid questions. It's one of the key ideas behind Cup of Cosmology. There are actually rules for Cup of Cosmology. They're on the webpage. And the first one is that there are no stupid questions. So you should never feel bad about anything that you ask me on the show. This is exactly the place to ask anything you've ever wanted to ask a scientist. This is what the show is for. Okay, let me go back because I know there were a lot more questions and I'm slowly getting through them. You answered that one about the CMB. Okay. Comment from Scott, if it makes you feel better and feeling at everything lately. I don't believe that's true. Everyone has strengths. Everyone's good at some things. We all go through bad phases. Don't be too hard on yourself. I answered those questions. Let me see. Okay, yes. Just seeing people saying that some of you wanted to be at my talk last Friday. They are going to upload the video. I think it was so chaotically organized. I know it was recorded, but only because I reminded them to record it. I have no idea what's happening with that recording, but if it becomes publicly available, I will link you up to it. Okay. Comment from Paul, Doctor Who used anti-plastic against the plastic creatures in the first Eccleston episode. Yeah, I love Doctor Who. I really, really do. It's a great show. At its core, it's about hope. It's about humanity. It's about curiosity. It's a show that encapsulates a lot of things that I like and a lot of things that I stand for. but it is also science fiction. And if you try to understand the science in Doctor Who, it falls apart very, very quickly. I like that most of the time they don't even bother. Most of the time they don't even bother with the scientific explanations. It's just literally, it's timey-wimey. And I'm losing my voice again. So I much prefer sci-fi shows that just don't even bother. It's just like, we have an exploding star at the center of the stardust, deal with it. I much prefer shows that do this than ones that try to give scientific answers and bullshit you and fail spectacularly. And I am cursing a lot today. I know exactly what's caused this. It's not random. Okay, but there was a sci-fi show that I watched last year that at some point they're traveling through a random part of the universe and there's flashes of light going through next to the window, and someone on the spaceship says, "Oh, that's probably heated up dark matter." And I was like, could you not, please? It takes out, just give me some bullshit explanation, some random sci-fi word, make it up, call it timey-wimey, I believe it, but don't try to put science in science fiction because then everything breaks down. Oh, okay, today is a day for ranting, I see. This is, again, do you know what is causing this? Okay, back to questions, let's see. Do keep the questions coming, as always. It's always great fun. Comment from James here. How connected is current quantum research with cosmology? Do cosmologists read quantum papers as much as their own? This is a really nice question, James. And it very much depends on who you ask and what your research you're trying to do. Now, one of the biggest open questions in physics is trying to unite the quantum world with gravity. So gravity works very well on large scales. It tells us how things move in the universe. It gives us a lot of stuff, but we have no idea how to marry or how to put together the gravitational force with the quantum universe. When you go to microscopic scales, our theories don't really add up the way we expect them to. General relativity is at its core very predictive, very deterministic. Quantum physics is full of uncertainty. You can do an experiment and the outcome is not decided until you observe it. So putting these two together is extremely difficult. And there's a lot of people working on this. So people who are trying to work on a theory of quantum gravity, like string theory or quantum cosmology, these people will absolutely be reading quantum research. Now, there's also other aspects of it. I'm interested in physics that happened in the very, very early universe. Some of these processes are quantum by nature, but then they evolve into classical processes that we study. I don't personally stay too up to date with quantum physics papers, but I do try to stay up to date on quantum gravity because it's kind of like a side hobby of mine. It's not something I'm ever going to work on myself, but it's something that I'm interested in reading up on. So it's something that I do try to stay more or less aware of what's happening. But in general, it very much depends what you're working on. There's a lot of stuff you can do in cosmology that is very, very far removed from the quantum world. Now, personally, I've been keeping up with quantum physics research over the last term because I was just the teaching assistant on quantum physics course, and I had to relearn everything I knew about quantum physics. So there are a lot of people who are working on bringing these together, but oftentimes they're very, very different, very, very different fields. So it's also the thing that there are just so many topics in cosmology to keep up with that if I also try to keep up with quantum gravity and with the quantum papers and condensed matter papers and all of the other cool stuff happening in physics, there's just not enough time. There's just too much fun physics to do and not enough time, which is why we have to pick a topic and focus. Or do what I do, pick a topic, focus on it for 2 years, and then change to a completely new topic and focus on that. That way you get to learn about all of the cool stuff and become, like jack of all trades, master of none, something like that. Or in my case, just become a general expert on everything that I try to work on, which is way too many things, but it means I get to explore fun topics. Like dark matter, CMB, inflation, I did a project on exoplanets at some point. Really fun, really fun. But I know that you people are asking me one thing, and I'm answering like 20 different things today. I'm slightly hyped up today. But that's good because being hyped up means that I can answer more things and have more fun. So yeah, some people keep up on the literature of quantum research. Some cosmologists do, some don't. I would say that most don't unless they're working on that topic. Okay, more comments, more comments. The Deanna hotline is open 24 hours. You can message me at any point. I do not guarantee that I will actually respond at any point because I do try to do things like sleep and have a life outside of computers. But you can always message me and I will do my best to get back to you as soon as possible. So never, the contact at cupofcosmology.com email address exists for a reason. It's linked to on the Cup of Cosmology webpage. And you can email that at any time. And when I have time, I will get back to you. Okay, seeing a lot of comments there that I will catch up with. Deanna of all trades. Yes, that's something. that's something. Yes. Okay. Let me go back here to the comments. So comment. I know my brain is very scattered today. I do apologize for that. It's been a weekend. Okay, question from Paul. At your level, do things change much from semester to semester as they do for an undergrad? So at my level, in terms of the research I'm doing on my day-to-day life, not at all. I know that terms are a thing based on when the students in my office are around, based on when the students have exams. The way it changes for me personally is if I'm teaching a course, then of course I need to be following the term schedule and teaching or being the teaching assistant on a course. I took a course this last semester on pedagogy, how to be a good teacher, something that I feel like a lot of university professors could benefit from. Not enough of them take it. The pedagogy course was very interesting. It was an interesting thing to do, and I definitely learned things from it. But that meant I had to stick to a strict schedule. But most of the time, it doesn't matter. What I was doing last 2 months ago in terms of research, what I'm doing now, it's not tied to semesters. Of course, for an undergrad, it is because you go through your studies. But now I'm at the point where, for better or for worse, I set my own schedules. I set my own research timeline. Of course, there are some deadlines. There are some collaborators that will always have deadlines. There's always something you want done by a certain date. But it's very flexible. I'll go into the office tomorrow and choose what to prioritize, what to work on, which of my ongoing projects I should work on tomorrow. Probably I'll decide I should actually start working on the slides for Friday. But it doesn't matter. I could do this tomorrow. I could do this a week from now. I could do this in 2 weeks. So semesters don't really matter so much unless I'm either teaching a course or attending a course. Coming from Angela, I'm speaking at hyperspeed. Yeah. That's a thing today. Comment from Scott. Does that mean you prefer Star Wars to Star Trek? So I am named after a Star Trek character. Personally, I have seen more Star Wars than Star Trek. I really like the politics that Star Trek takes on the topics that it covers. And I'm amused at people who make comments like Star Trek went woke. It's like, have you watched any of the originals? Because that's literally what Star Trek has always been. I like Star Trek. I like Star Wars. It's not an either or. Both have good things. I never like picking between two options. Why give me two options? My answer to that is always going to be both. And unless it's something blindingly obvious. But if you ask me to pick between two options, I'm probably going to answer with both. And yes, it's already pointed out here that I was indeed named after a Star Trek character, named after Deanna Troi. So my legacy was already set before I was, of course I ended up being a physicist. What else could I do? I'm going to drink my tea and then get to the long comment from Scott here. Quantum mechanics scares me because one day you're talking about cats in boxes and before you know it, you've got the Modoc and the Conqueror. Yeah. Quantum physics is fun and crazy and can do a lot for us. And it's also something that we fundamentally are still trying to figure out. There's a lot of open questions. I love when you first encounter quantum physics as an undergrad. Because, some undergrads in physics can be a bit cocky. Some physicists in general can be a bit cocky. And you start going through your undergrad and you're like, okay, I'm getting the hang of things. I've understood classical mechanics, starting to see electromagnetism. You're getting a feeling of how things work. And then suddenly you're hit with quantum physics and you go in it thinking, I know my stuff. And it's like, take everything you knew about physics, throw it out, and let's go from here. And then you learn things like how you do the observation affects the experiments. that there's randomness and that things are not predictable, and that something can exist in two positions at the same time, that there's superposition and everything you know about physics, and you're just like, okay, I know nothing. I think studying quantum mechanics is both extremely fascinating and extremely humbling, because it reminds you that actually we do not know as much as we think we do. I'm only, scientists cocky. What? I know, right? It's unbelievable. Have you met scientists? Some scientists are lovely people. Some scientists really are. Some people in science. Science has a mixed bag of everything. There's always going to be good people. There's always going to be bad people. Unfortunately, the academic system is set up in a way to favour, let's say, not good actors, and people who perhaps are not the nicest of people. And then there's the survivorship bias, where people who have the power to change academia won't change it because I survived academia, so it can't be that bad. Yeah, anyway, there's going to be cocky people everywhere. There's a lot of arrogant, cocky scientists, but there's also a lot of amazing people in science. It goes both ways. And people who know me well know that there's a full rant that's just waiting to come out here, and that I'm pushing to the side specifically because I'm already ranting enough as it is. So let's leave that one aside. Comment from Scott: you were just pointing out that Star Trek tries to use scientific principles where Star Wars doesn't even bother. You know, on that note, I was with Star Wars, the Force, whatever, right up until they tried to do the thing of actually it's midichlorians. I know a lot of fans have issues with that. Me too. That makes no sense. Anyway, yes, don't give me a scientific explanation. Just say, it's something. I don't care what it is. Make up a term. Tell me you reverse the polarity of something. I'll believe it. But yeah, don't tell me that it's dark matter when it's emitting light. That one in particular really bugged me because there were so many things I disliked about that show, and I was just, at some point I was just hate watching it. And then they did this with dark matter. I was like, you know what? No, I'm done. I'm done with this show. The comment here. You asked a question on Twitter live chat. Can you take a look there? Please do repost it here. For some reason, Restream isn't pulling in the comments from Twitter. So if you reply to the stream on Twitter, it's actually the Twitter API that is broken. It's not Restream. Of course, Twitter is a dumpster fire these days. The API is broken, so Restream is not. I'm doing the stream from Restream, so that goes to Twitter and YouTube, as you can see with the branding up here, that I can't remove unless I pay for it, which I'm not going to because it's expensive. So unfortunately, I'm not getting any of the comments on Twitter. You can either head over to the YouTube channel to join the conversation, but if you've asked me something on Twitter currently, I'm not going to change screen and open up Twitter. So please do post it here again. It will be much easier. Which show was that? That show was called Afterlife. I believe Afterlife. Either Afterlife or Another Life. It is not a good show. I do not recommend it. It got cancelled after season 1, and I completely see why. Okay, there was a comment by Ben before. I'm only 9 minutes behind on the comments now. I'm jumping between current comments and 9 minutes behind on the comments. Get through all of them at some point. What's the importance of determining whether the universe is flat versus closed, and how does that relate to the CMB? Excellent question. I love this question. So we know that the universe is homogeneous and isotropic. This means that the universe looks the same in any direction you look from wherever you look. There's no privileged position in the universe. No ranting. There's no privileged position in the universe. Whichever direction you look in the night sky, you should see the same. Now, we know on small scales this is not true. Looking at a galaxy is not the same as looking at a void. But when you take a step back and look at the overall scale of the universe, there is no privileged position, and it's the same in any direction you look. Armed with this information, there's only 3 possible topologies, or like shapes that the universe could take. And the reason this is interesting is because it tells us a lot about how particles move and how things should behave in the universe. And this is something that is quite difficult to think about, because the universe we know is 4-dimensional. There are 3 space dimensions: up, down, left, right, in, out, and 1 time dimension. So when we talk about what it looks like, we're trying to imagine this kind of 3-dimensional object. So it's not easy. But once we've assumed that the universe is homogeneous and isotropic, there are 3 possible configurations. You can have a spherical universe, as you can see here at the top. You can have a saddle or Pringle universe, which is what we call an open universe, or you could have a flat universe, which is what you see here at the bottom. Mathematically, the way we describe this is whether you draw a triangle somewhere in the universe and you add up the angles. If you get 180 degrees, the universe is flat. If you get less than 180, it's an open universe. If you get more than 180, it's a closed spherical universe. Now, of course, by this, we do not mean that the universe is like a two-dimensional piece of paper. It just means that the overall topology of the universe has to be one of these three things. This is something that is quite difficult to kind of wrap your head around. And the reason it's so interesting is because it really tells us a lot about both what is happening in the universe now and what happened in the very early universe that could have led to the universe that we see today. So what happened in the first few seconds of the universe, which will look the way it does today. Currently, all of the data, most of the data we have point towards the universe being flat with pretty much very, very small margin of error. So up to like 0.5% precision, the universe must be flat. The biggest data point we have for this comes, of course, from the cosmic microwave background radiation. If you have a different geometry in the universe, this would look rather different. However, that's not the end of the story. You can also use things like galaxies. You can use a lot of different probes to measure the shape of the universe. And overall, most of the data points towards this being a flat universe. However, if you only take a subset of the CMB data, so the cosmic microwave background data, there's lots of different data sets here. Even from Planck, there's different parts of the data. And depending how you splice up your data, you can find a slight preference for a curved universe. Now, of course, one could very easily argue that you shouldn't cherry pick the data and you should take all the data. And if you take all the CMB data, we don't find any evidence for non-flat universe. But there are some hints that there could be something more to the story. It's not a fully finished story just yet, but we can measure the curvature of the universe from the CMB. Okay, going back to comments, I know there's some at the bottom. I will try to catch up to everyone now. Answered that one, answered that one, answered the Twitter one. The full phrase is jack of all trades, master of none, but better than master of one. Yes, I like these phrases that should mean one thing and that people have cut them in half and then they end up meaning something completely different. Like there's also that one of like the blood of the coven is thicker than water or something like that. Something about that if you only take the first half of the sentence, it's like family is more important. But if you take the full thing, it's like your chosen family is more important, you know. So blood of the family is thicker. I cannot remember the phrase. But yeah, the full phrase is jack of all trades but master of none, but better than master of one. Yes. So that's me in my research. I go through different topics. I know that was already like 10 minutes, 12 minutes ago. I'm coming back to that now. For anybody who just joined in the middle, I know this conversation might feel all over the place, but somewhere in my brain there is a structure to what we're saying here. Comment from Scott here. It applies to every facet of life. Assholes prosper and nice guys finish last. Sometimes, yes. Unfortunately, yeah. Not always. There are some places where people really do try to make an effort. And I do think that humans are in general very nice, very good, very kind. We are a good species. Sometimes you just need reminding of that. Do we know if there are black holes that aren't rotating? If this black hole starts feeding, will it force it to rotate? Excellent question here, James. So the thing is, we know that angular momentum is conserved. If you make something rotate, it's going to keep rotating unless something stops it, unless there's friction or air resistance, of which is not much of in space. There's no air resistance, there's barely any friction, no meaningful friction. That means that having objects rotating is going to be much easier than having objects not rotating, because anything that could start something spinning is going to keep it spinning. Now, black holes, let's say we look at stellar mass black holes, so black holes that are formed when a star reaches the end of its lifetime and it collapses, so stellar black holes. Most stars are rotating. So then when the star collapses, it's going to be rotating as well, and the black hole will be rotating. Likewise, the collapse process itself and the resulting supernova might not be symmetrical, and this might give it a kick to start it rotating. Mathematically, non-rotating black holes can exist, but it's really, really difficult because what you're saying there is that of all possible values for the rotation, you want it to be exactly zero. And if it's anything that's not zero, it's going to be spinning. So it's very difficult in nature to find out things in the universe that are not spinning, especially if then you consider you have the whole angular motion of the galaxy and everything. So there is always some angular motion to consider. But mathematically, you can have non-rotating black holes, but physically, it becomes a bit harder to actually imagine how you would create a black hole that's not spinning. Then, of course, if we have primordial black holes, which are black holes that are created in the early universe, these are black holes that are formed by a region of space-time itself that is so dense that it directly collapses to form a black hole without going through the whole star phase. Now, in this case, these primordial black holes could be non-rotating because the way they're formed is perfectly symmetrical, in which case then the only way they could gain rotation is by having something interact with them in some meaningful way. So you can envision scenarios which would lead to non-rotating black holes. But in general, black holes rotate. Afterlife is definitely not something with science in. Yeah, it might have been called Another Life or something like that. I can't remember the name of the show that I keep disparaging. I've just kind of purged everything I could of that show from my brain. Midi-chlorians never got brought up again, at least in the main canon. Yes, they should never be mentioned in the first place. Okay, the name dark matter makes me think of it as a clumpy, blobby black lumps. Do you think the names used make it harder for cosmologists to think about? Absolutely. We are notoriously bad at naming things. We call it dark matter because we can't see it, where calling it invisible matter would be much more logical. Because then there's a confusion of dark matter and dark energy. Are they the same thing? No, they're completely different. They're just dark because they're mysterious. So we are notoriously bad at naming things, and that can lead to misconceptions. There's an interesting etymological debate in the field as to what we actually mean when we say Big Bang. And if you say Big Bang in a scientific perspective, we usually mean after inflation. Whereas when we talk about Big Bang in popular science, we usually mean the start of time. And then you get fun people putting out popular science articles that say something happened before the Big Bang and they mean before inflation. And then it's just how you define things. So yeah, the way we define things actually really does shape how we study them. And I think that's a problem that goes beyond dark matter. The language we use to refer to things does shape the way we do it. Especially we always use English as our main language in science. Most science is done in English, and this already adds bias to everything because then we're biased by the words, by the vocabulary, by the structures in English itself. Whereas other languages use much different vocabulary and structures, and even the phrasing of sentences or what you give importance to. The way you use words in a sentence gives meaning to it. This is something that is highly language specific. So not only the word dark matter, but the language we use to do science affects how we do science. Because a lot of science is done in English, this adds a very Western standpoint to everything, like we're doing this in English and this is absolute and this is truth. And this is not necessarily the case. And I know I'm going off topic here, but yes, the names we give to things really do matter, and they do affect how we see things. I think calling dark matter invisible matter would be much better, would be much more reasonable. But unfortunately, this is the name we have. Calling it invisible matter would make more sense, but now it's dark matter, and we're not going to change it now. I just see a comment here. The wheels of capitalism are oiled by the blood of the workers. I have no idea what that's a reference to, but I'm just going to agree with that. I guess that's when we were saying like the blood of the covenant or something like that. Right, yes, the phrase that I was trying to think of is blood is thicker than water is butchered from blood of the covenant is thicker than water of the womb. Yes, exactly. Thank you. That was the phrase I was trying to think about and ended up with the blood of the covenant. Yes. Thank you for that. Thank you for clarifying that. Okay. Can the speed of light be considered as a dimension? Like right next to ours, could there be other universes where c is 1 Planck length? This is really interesting. Now, I'm not sure how you would make the speed of light a dimension because it really behaves more like a constant in the universe. It's a value that we measure. Now, you can work. So when we play about with general relativity, you define a metric and you work in that metric. And usually at that point, to make our lives easier, we do set the speed of light equal to 1 just to make our life easier. And we often do this where c is equal to 1, and then at some point we need to add it back into our equation. But you can construct a system where you set the speed of light to 1 for convenience. But I wouldn't really call it a dimension. So we use the dimensions, the three space and time dimensions, to give position and kind of tell us how things are in the universe. Like if we give the dimensions of something, it's where it is and at what time. Whereas the speed of light is more a property of some things in the universe. So I'm not sure how we could consider the speed of light a dimension. I think they're quite different concepts. But when you are talking about the speed of light, you can set it to 1, and we do this frequently in our equations because it's just convenient. Most physicists will start any problem with, okay, set c equal to h equal to 1, all constants equal to 1, life is simple. And then at the end of the day, you figure out what units you need and you add back in the corresponding things like, oh, I'm missing a c squared here, okay. But yeah, I don't think, I can't really see how we will consider light to be a dimension, because it's more of a property of things rather than something that tells us where an object is or at what time an object is. Hope that answers your question. If not, feel free to ask again and we can come back to this. Dark matter equals clear matter. Yeah, dark matter is invisible matter. It's much easier. Okay, let me just check new comments, then go back to old comments. Okay. I do realize that I'm speaking very fast today. We're jumping from topic to topic, which is always fun. And I love when we do this and then the stream ends and my brain crashes. I'm like, whoa, that was exhausting. But I love that we jump from topic to topic. It's always really fun. And I'm slipping in lots of rants throughout today as well. Yeah. So, comment from Paul. Oh, only 11 minutes ago. I felt like I was catching up and now I'm still 11 minutes behind in the comments. I heard a theory that universe constants might be on a gradient slope rather than constant everywhere. Do you think that can be dismissed because isotropic principle is very well supported? So that's a very interesting question, and it's something that people are actively investigating. There are some things that we know are constant here, and it's always a question of, is it also constant everywhere else in the universe? One example of this is Newtonian's gravitational constant. This is something that appears in a lot of our equations anytime we do gravity. And is that the same here as elsewhere in the universe? And we're trying to do a lot. There are a lot of ongoing experiments testing this. For now, we haven't been able to find any deviations. The same as the speed of light or the mass of the electron. These are things that we're pretty sure are constant now. Then there's the other question of, are they constant in time? And that's something else that we're investigating and looking at. So there is the possibility that the constants that we measure now are not constant everywhere in the universe or every point in time. But currently we haven't found any deviations. But it's something that we are trying to study. So we are open to the idea that constants could change, especially within different parts of the universe. Especially in regions like if you write a code, you always want to test the edge cases, the cases where the user might break your code. And those are the ones you want to make sure you catch. It's kind of the same in these things. We want to test the edge cases. We know that gravitational constant is pretty established everywhere we've checked. But what if we go to an extreme region where there's a lot of mass, like the center of a galaxy? Or what if we go to a void where there's no mass? Does it still behave the same? And these edge cases are the ones where we can really test the consistency of everything. So it is possible that constants change in time. And then scientists, going back to the thing of being bad at naming things, and there's some things that we call constant that are not constants, like the Hubble constant. The Hubble constant is not constant. The Hubble constant changes in time. The Hubble constant gives us the expansion rate of the universe. We always talk about the Hubble constant, and the Hubble constant is usually the Hubble parameter measured today, but it's not a constant, it changes in time, but we call it constant. It's constant in space, so we call it a constant. Yeah, scientists excellent at naming things. It's a theme. The wheels of capitalism are oiled by the bloods of the workers. Again, I have no idea what the context for this was, but that's fine. Comment by Scott, most stars are rotating, you mean some don't? I don't think we found any stars that aren't rotating, but again, there could be some. Stars generally rotate, but we could find some that are not rotating depending on how they're formed. In general, to my knowledge, every star that we've been able to find is rotating, but that doesn't necessarily mean every star is. Okay, the problem with being delayed with comments is that there are things that seem completely random. Like now there's a comment saying, smash that like people. Right, just telling people to like the video. Thank you. I was just like, smash that like the people. And I was very confused. Yes, do like the video, subscribe, leave a comment, all the usual YouTube things. Thank you. Remember, Calvin wanted to sell scientific names because so many were lame. Yes. Yes, scientists are very bad at naming things, and I do believe I am caught up on the comments now. Yeah, scientists are bad at naming things. It's just an ongoing thing now. We're not good at naming things. I apply that to everyday things. Like once I've latched onto a naming convention, I will use that naming convention for everything. So yep, we're bad at naming things. Question here of why is there stuff? And this goes back to what we were saying earlier. I can do a nice like tail here, head tail thing about antimatter and matter. Why is there more antimatter? Why is there more matter in the universe than antimatter? We have no idea. There just is. We don't know why there is stuff, but if there wasn't stuff, we wouldn't be here to have this conversation. A universe without stuff would be very boring. Why is this stuff? Where did this stuff come from? We're figuring it out. We're getting there. Why is there more stuff than anti-stuff? We're getting there. We'll figure it out someday. So yeah, there's a lot of big questions that we don't know the answer to, and why is there stuff instead of not being stuff is one of them. Then it comes down to where do we blur the line between science and philosophy, right? If you look historically, a lot of philosophers, a lot of them had cosmologies as well. They had opinions on the universe, the creation of the universe, and now this is something that is left to cosmologists. So then it's a question of where do we draw the line between philosophy and physics sometimes. And questions like, why is there something instead of nothing? Why is there a universe? Why do we exist? Why are we even here? What came before time? These are all very philosophical questions that becomes quite hard to answer from a mathematical point of view. And then you could ask the question of, is physics just something that we can answer mathematically and work on and do theories and do conjectures and do stuff like this? Or are we allowed to add a bit of metaphysics into the mix as well? When we start talking about why is there something, why are we here, why are we in a universe that is just so happens to be fine-tuned for our existence, how do you actually answer these questions? This is something that we haven't completely figured out yet, but it's very cool to think about the fact that we might never get all of these answers, and that maybe we'll never know why there is something instead of nothing, and why there was more matter than antimatter. Maybe we'll never know why we just happen to live in a universe that accommodates life. But these type of questions are something that humanity has always wondered about. It's something that does crop up in physics, especially when we're trying to deal with these big questions of the universe. So it's a very interesting question. Why is there stuff? I have no idea, but I'm glad there is stuff, because if there wasn't stuff, I wouldn't be here thinking about why there is stuff. Is that a satisfying answer? No, but it's the best we've got for now. You remember in the series finale of Star Trek The Next Generation, Picard asked Data if there was anything unusual, and he said that every region of space had unique properties. Well, not to our knowledge, no. Again, science in sci-fi films. I love sci-fi, but don't use it as a scientific reference. Usually, they're not a reliable source of actual science. For taxonomists, naming things is the job. Yes. Yes, you can use the annoying, yes. What's the matter with antimatter? Yeah, what's up with antimatter? We don't know. Antimatter matters. We'll figure it out someday. The more I ponder my existence, the more I want to not exist. You know, the more I ponder my existence, the more I'm confused by my existence. One thing I am very good at is overthinking. I do not want to start overthinking why I'm here overthinking and why I exist in the first place. I'm just happy that I do. I do not mind you speaking at 100 miles an hour and changing subject every 5 minutes. I have ADHD and have zero probability of keeping up. Yeah, I know I've been jumping about a lot today. Some days I try to stay more focused. I notice I'm speaking quickly today, but yeah, I was just hyped up a bit today. Happy about a lot of stuff in the universe and about science in general. If I am speaking too quickly, please do let me know and I will try to slow it down. The good thing about having the shows on YouTube is you can watch the replays and slow me down manually. I know I talk a lot slower than I used to, but some days I still get carried away. We do jump about a lot because of all the people popping up asking questions. Some days we do stay on topic. Today's been very chaotic and all over the place, but I think I managed to answer or at least respond somewhat to all of the questions, often without actually providing an answer. No, I ranted a bit today as well. Haven't heard any news on LIGO. Are we still detecting events? Love that question. Love that comment. LIGO is one of the Earth-based laser interferometer gravitational wave observatory. It is one of the ground-based gravitational wave observatories that we have. It is bouncing lasers back and forth down 4-kilometer arms to see if there's any deviations. I'm looking for the ripples of black holes smashing together. It is absolutely amazing. It is really, really cool that LIGO is a thing. We do, gravitational waves are one of the most amazing things in the universe. They are just these tiny, tiny ripples in the fabric of space-time that are ridiculously small and ridiculously difficult to detect. And rather than saying, like, no, we'll never detect those, humans went, you know what? I'm going to use lasers to detect gravitational waves. And it works, and it's amazing. And I love that this actually works. To answer the question, LIGO is currently under maintenance. LIGO was shut down at the end of 2020 to go undergo upgrades. It is getting upgrades, getting a makeover. It is going to come back more precise. And the observing run 4 of LIGO is set to start in March, in 2 months. They're going to switch on the machines again and go back to listening to whatever the universe has to throw at us. So yeah, it's really cool. It's amazing. Gravitational waves are such an incredible topic. We are highly lucky to be living in the age where we can measure gravitational waves, where we have 90 confirmed events, where we're going to get a bunch more, we hope. So yeah, it's amazing that we're at a point where we can actually talk about all of these gravitational waves. It's no longer a big story, but it still is. It's incredible that we're measuring these and doing this. LIGO is an incredible detector, and it's going to turn on again in 2 months to take even more data. Can't wait to see what it shows us. And if you're hyped up about LIGO, there's an even more incredible one coming in 15 years, which is LISA, which is the space-based version. We're taking LIGO and sending it to space, or LIGO experiment, we're sending it to space, and we're hoping to listen to the afterglow of the Big Bang itself, like these initial ripples produced in the first fraction of a second of the universe. Can't wait for it. Yeah, I realize I misread your comments. You actually read your comment there. You have zero probability of keeping up. I realize now that you said you have zero problem keeping up. I'm glad. I'm glad that me changing topics constantly is not losing people. If it is, I apologize for that. But I do like jumping from topic to topic. Keeps it fun, keeps it fresh, and keeps my mind active, which is either a good or a terrible thing depending on the day. So yes, we are going to have more information from LIGO very soon. Okay, comment from catch my breath after doing that. What kind of events can LIGO detect? LIGO can measure black holes smashing together and neutron stars smashing together, and black holes and neutron stars smashing together. Once we launch LISA is going to measure, hopefully, gravitational waves coming from early universe processes, gravitational waves coming from supermassive black holes crashing into other supermassive black holes, from small objects falling into big objects, also from white dwarfs smashing together, neutron stars and binaries. Anything that produces gravitational waves, LISA is going to be there waiting, trying to hear it. I get to work on this. I get to spend the next 15 years, hopefully, trying to get ready for when LISA launches. I don't want to imagine what state I'm going to be in the day LISA launches, but at least that's 15 years away, so we don't need to worry about that just yet. Instead, I can get stressed about Euclid, which is launching this year. Going to be an absolute mess about Euclid launching this year. Whew, okay, Diana's trying to speak faster than C. Yeah. I can calculate c squared in my head, but only when I set c to 1 first. Yeah, I set c to 1, it makes everything so much easier. Just really, really makes things a lot easier if you set c equal to 1. Just set all constants to 1 and fill them in later. Okay, a comment from James. Playing here, is it possible to see light but not the source of the light? Interesting. Yes, we can measure photons all the time without necessarily knowing where they're coming from. Is also one example we can give here is that if you have an atom and you have an electron in a higher energy state, you know, the universe likes being lazy, everything likes being in its lowest possible energetic configuration, and sometimes an electron can fall from a higher energy state to a lower one and emit a photon, a particle of light. Then you can receive this photon, but you won't be able to actually see the source necessarily. So you can have a lot of photons in the universe that you can't necessarily point to a source. Then you can do the cool thing that the photons you see coming from the sun actually took like 2.5 million years to escape the sun, because it's not the same photon. Photon is created, absorbed, and for a photon to travel from the center of the sun to the surface of the sun takes about a couple million years. So yes, you can sometimes see photons without directly seeing the source, and I think that's a very fun question to think about. Okay, comment from David Howden here. We have a lot of Davids here. Only lost track because my computer crashed. Yeah, computers like doing that. Many hours of entomological data entry not backed up. Oh, I hope you can get that data back. No, it's always terrible when you don't have data backed up. Sorry for that. Why is it pronounced Lisa or not Lisa? That very much depends who you ask. You know, I change how I pronounce it all the time because I've heard both. Some people call it Lisa, some people call it Lisa. I think it also depends where you're from, because Lisa is a common name in different parts of the world, and everyone pronounces it differently. Like the German Lisa is not the same as an English Lisa. So I think it very much depends on if you think of it as a name. It's an acronym. So technically we should call it the LISA, right? Because it is actually an acronym, but nobody does that. The same as NASA, we don't call it NASA, even though it is an acronym, or ESA, European Space Agency, same thing. So you can pronounce it Lisa, you can pronounce it Lisa. People do both. I will change depending who I'm talking with at the time. Yeah. Question from Paul here. I was about to say we wrap up, so I'm going to take this last question from Paul, which is going to be a bit of a rant, and then I'm going to wrap up. Have you talked to ChatGPT? I have not. I do not approve of it. I am not going to use it. I don't like it. It's a machine that is very, very good at giving what seem like good answers, but it's actually just giving you absolute bullshit. You know, it's artificial intelligence type chat things are trained on an existing database. They're very good at pulling out what they think you want to hear, but it's basically a glorified autocorrect on your phone. You know, you start typing on your phone, it predicts the next word. This is what ChatGPT is, but taken to the next level. It is trained on an incredibly good data set. Any conversation you have with it is used to further the training, so anything you add there is going to be used to train it. And it can give you very plausible sounding answers that actually have no content, kind of like how a lot of politicians talk, or a lot of people at seminars who do that. I have more of a comment than a question, and they're actually just talking nonsense and pretending to sound smart. And this is what ChatGPT does. It gives you answers that may or may not be accurate with utter confidence. It's like, I am very confident about this nonsense that I've been programmed to tell you. We're not going to gain any insight from it. It's something that, you know, I think it's fun to play about with. Like, it's fun to play something on your phone of start the sentence, see how autocorrect predicts the rest of it. But I don't think it's in any way something that is useful. I get why there's a lot of hype about it, but yes, it's just something that will give you an arrogantly incorrect answer, and I have enough of that dealing with physicists. So no. And also, I really, really don't like people using AI to do art, because what that does is it steals artists' designs, it's trained on existing artists, and it produces something that is not art. Art is not just about painting or doing something. It's about the emotion you put into the piece and how the other person understands it, right? Art is a conversation between the artist and the person interpreting the art. The artificial intelligence takes all of that out. It is stealing from creators. I do not approve of art done with artificial intelligence either. Oh, okay. So yeah, that's a good rant to end the show on before I go into another rant, because there's been a lot of that today. Since you were speaking so fast, it meant show would be 2 hours today. I can't do 2 hours at this space. I feel like I packed 2 hours of content into this 1 hour show today. So it's definitely a good time to wrap up and and bring this to an end. But yeah, we did cover a lot today. Now I always try to like do a mental recap after the show. What did we talk about today? We talked about everything today. We jumped about a lot, and it was great fun. I love this. It really does remind me of the Periscope days, where I would start on Periscope and the questions would come so quickly that I couldn't keep up. And I had that today when there were so many comments behind. So it's great fun. So yeah, thank you everyone for this amazing conversation. It's been great fun. I know we've had a lot of cool topics, and yeah, it's been really fun today. I know I ranted a bit, cursed a bit more than usual. Something put me in a bad mood this afternoon. Something actually science related, not really. Yeah, something science related put me in a bit of a bad mood this afternoon, but that's all gone now. Hopefully, I'm still going to have voice tomorrow. Tomorrow I'm going to get to work exhausted. Like, I can't talk. I just spent an hour chatting at super speed. Anyway, thank you, everyone. This was really, really, really fun today, as always. If you haven't done so yet, please do subscribe, like, leave a comment, all the usual stuff, share out the link. You know how YouTube works, boost the audience, really do appreciate it. So, Cup of Cosmology should be online next Sunday, same time as today. That's 7 p.m. Central European Time, 1 p.m. if you're on the east coast of the US, 10 a.m. if you're on the west coast. There's a time zone converter on cupofcosmology.com, so you can always catch the show in your own time zone. And I always put out the links to the streams 24 hours in advance on both Twitter and Mastodon. I am honestly mainly using Mastodon these days, but the all Cup of Cosmology news will still be on Twitter. So, yeah, you can follow me on either of those to get all Cup of Cosmology news. I will be back online again next Sunday, same time as today. I hope you all have a great week, and I hope you will take care of yourself. I messed up my ending there. I hope you will stay safe and take care of yourself. That's how we end.